is
This
the difference?
conference will now be recorded.
What is the main difference between the data warehousing and the big data? Okay, what is the main difference? Why we require the big data concept instead of data warehousing? So what is big data? What is the data warehousing for us? Guys, what is the data warehousing?
It is a combination of multiple variable sources into the one data warehouse.
So the data warehousing is nothing but so we are extracting the data from sources, different sources, okay, and then we are ingesting into the in one system, that a unique system we are going to unique format we are going to ingest, okay, for analysis purpose. Data warehousing is analysis purpose. So what kind of formats we are going to use in the data warehousing means data warehouse formats. So what kind of sources we have, from where and all we are getting the data, and which kind of formats we are getting the data?
Table, flat file.
Yeah, tables is structured. Table is nothing but a structure, right? Structured data, structure format is there. Proper structure will be there for the tables. And then semi-structured. Semi-structured is nothing but the flat files, CSV or TXT or anything. This we call as semi-structure. Some kind of structure will be there. Okay. So these two kind of formats of data we are getting from the, we are extracting the data from the data warehousing. Structured data, semi-structured data. Okay. And then maximum will be how much size we are going to extract, how much size we are going to process means 1 TB. Okay, up to max is very difficult. 1 TB was very difficult. Means it will take a lot of time to process the data and this kind of data. Okay, in data warehousing. Okay, but this overcome. For example, we have the now analytics is coming. It's video analytics. Okay, so whenever you go just central shop, any mall, you can take the anywhere. So based on your interest, for example, take the central only. The 10 times you went to the central, okay, but you didn't buy anything. Okay? Just you went and then you have seen the some different products, brands you are going to look, and then you are just coming back. So based on your interest, for example, if you like flying machines or Nike or Pumas or whatever you are like, so every time you are just going and seeing and then you are coming. Okay, so based on that, based on your movements, so they are going to capture the video capturing. Okay, video capturing, and then based on your, they are send the promotions. So these are the promotions are there, these are the promotions we are getting. Okay, so those kind of, now in future we are getting those kind of feature functionalities. Okay, based on the video, audio. Okay, and then take the social networking. The social networking like Twitter, LinkedIn, take the Twitter, LinkedIn, Facebook, anything. So we are getting kind of the different data generating, right? So what kind of data generating? Non-structure, right? Those are the, these are structure, these are semi-structure. Yeah. So different images are there. Okay. Videos are there. Charts are there. So different kind of data every day, millions of data it's going to generate. Okay. So non-format. What is the 1 second? The format name I will tell you. Yeah. Unstructured data. So this is called as unstructured data. Okay. These unstructured data, so we can't process in the two data warehousing. Means images we can't process, videos we can't process, we can't ingest the data from the source system to your target system to analyze. Okay, so this kind of data we're not processing the unstructured data in the data warehousing. That is the reason they implemented the Hadoop concepts, big data concept. Okay, it came to the big data concept. So in the big data, they're going to, along with the structure, semi-structure, okay, unstructured data also they will process. Big data formats. That is the only difference, guys. The remaining everything will be whatever we are doing, right? Validations, everything will be common for data warehousing as well as the big data. Only thing will be here is they are going to handle the unstructured data in the in the big data. Okay, structured data, structure format data, semi-structured, and unstructured. So the structure means RDBMS database. Semi-structure means flat files. So unstructured means images, videos, charts, in whatever we are getting the data. So different kind of data, like LinkedIn, take the Twitter, LinkedIn or Facebook, any kind of social networking site, they are following this unstructured data. Okay, video, now it is going to the video analytics, we are getting the video analytics. Okay, so these kind of data also they are going to process into target databases for analyzing purpose. Okay, that's why it is now will be it is happened that now most of the companies are going for the big data. Their existing projects, everything they're going to migrate into the big data, the cloud system. Okay, so here there are different kind of, and also the size will be here up to 1 TB, 1 PB, petabytes or exabytes, petabytes. For example, TB means what happened? 10 power, I think 3 something. I'll show you what is the petabytes. Petabyte structure, yeah. So see here. So this is the sorry, yeah, exabyte or exabyte. This is this much size they are going to process at a time easily. Okay, petabytes, 10 or 15. Okay, here we are processing a maximum will be at a time we are going to GBs you are going to process GB or TB. Max will TB also they won't process. GBs they are going to process in a day, daily data. Okay, but come to the big data, easily they're going to process a petabyte or exabyte data. This kind of huge amount of data they're going to process smoothly. Okay, that is advantage of the big data. Okay, so now clear, right? So they will ask in the interview point of view, what is the main validations difference with the data warehousing testing and the big data Hadoop testing? So as part of the validation, there is nothing, there is no difference on the validation part. Okay, whatever job validation we are doing in the ETL testing, the structure validation, everything will be common for here. Only the framework, here we are using the ETL tool, here we are using the big data framework. Okay, here the backend will be the framework, it will be handle the data, it will process the data, it will extract and then ingest the data by using the Hadoop framework, the big data framework. But here in the data warehousing, we are using the ETL tools like Informatica, ODA, Talent, like that. Okay, here the framework, it will be handle all those things. Okay, clear guys? Any doubts here? Big data, any doubt here? Okay, so the validations will be same guys. That's why I'm giving the last class why I'm telling it. First, if you understand the ETL testing or BA testing reporting, okay, the ETL, whatever we are doing the ETL side for source to target validations, the same validations we are going to perform in the big data also. Here we are executing the jobs, here we are executing the some data pipelines or jobs, we call it as jobs or data pipelines or airflows, depends upon the tool, depend upon the cloud environment. I'll tell you the cloud, what kind of cloud environments are there, I will tell you. Okay, so the mainly the big data consists of the three varieties. The mainly will be they're going to the classifications will be three varieties are there. One is the velocity, volume, and then variety. We'll see. First we'll go for one by one, guys. So whatever I discuss, the same thing will be there here. Okay. Big data is a collection of data that is huge in volume and growing exponentially with the time. It's a data with a so large size and complexity that none of the traditional data management tools can store it or process it efficiently. Okay. So other than the normal tools or data warehousing tools or any other tools, normal tools, they can't process this kind of huge amount of the data. Okay, so that will be doing the big data. Okay, big data also data, but with a huge size. Okay, so data that is too unstructured and the time consuming to be loaded into the relational database or for analysis. Here we are going to the unstructured data also along with the structure and the semi-structure. Okay, data that is too precious can possibly arrive at the priceless business decisions for manipulating expertly. Data sets through the grow large that they become acquired to work with the using hand data management tools. So the same thing which was just I explained, right? The same thing, different ways they are going to give the comments here. Okay. So you can see the we can't able to open 100 MB even attachment also we can't able to attach 100 MB file, right? So max 5 MB is going to attach in normal ways. The Gmail or anything, your Outlook or anything, you can take max 5 MB. More than 5 MB, then it won't even send also. It won't attach also, right? Even if you want to open the any GB, 100 GB data, image file or anything, so we can't able to open. For example, if you take the 600 MB or 700 MB file, Excel file, if you open the Excel file, click on the Excel file with the 700 MB or 1 GB Excel file, so you can't even open. It will take some time to 5 minutes, 10 minutes to open. Okay, so unable to view those kind of things, huge amount of the thing. Okay, so if you have GB is here, any kind of videos, okay, that also we can't able to do. You can't able to edit it. But these all kind of things you can able to do in the big data. They can able to transfer, they can able to edit, everything can able to do by using the big data framework. Okay, how data is measured. So what do we call as a kilobytes means 10 power of 3. That we call as a 10 into 10 into 10. That is kilobytes. So like that they are going to measure this kind of thing. But big data side it will come to the peta or exabyte data. They're going to ingest this kind of huge amount of data they're going to ingest into the, they're going to process into the by using the framework. Okay, so the mainly will be there. So volume they're going to handle in the big data. Velocity means speed, how much speed they're going to process. Means here you can take here. So this much of huge amount of data. For example, if you want to copy 10 GB, how much time it will take for us? The laptop we can take the 10 GB or 1 GB, 2 GB. So it will take huge amount of time. It will take, right? Half an hour it will take for 10 GB something to copy one system to another system. Normally copy paste. Okay, so that is the velocity is going to handle here. Okay, so first will be advantage will be size. Huge amount of data they're going to handle. Okay, and then speed. Whatever the huge amount of data is there, that huge amount of data how soon they are going to process. That is the next velocity. And then variety means different kind of data, means structured data, semi-structured data, unstructured data. So all kind of data format they are going to handle by the big data framework. Okay, that's why they classified as a 3 V's. One is a volume, velocity, and then variety. Okay, so all these three kind of features it will be handled by the big data concept, big data framework. Clear, guys? Understanding? So one is the volume, one is the variety, one is the velocity. Huge amount of data, the processing, and then format. So these three things will be handled by the framework. Okay. So same thing, just I explained the same thing here. Volume, what is the volume? What is the variety? What is the velocity? Okay. Clear, guys? Any doubt here? Volume, velocity, variety. Okay. So types of data. So types of data means the structured data is there, means database or DBMS data. Unstructured data. So data is stored in the unstructured format. Example: Facebook, Twitter, LinkedIn, anything. So they're going to store into the images, videos, and the charts. So all the formats they're going to handle the different in the same system. Okay. The semi-structure means the flat files. Semi-structure means the flat files. These kind of data they should going to handle by the big data. Okay. The challenges also same thing will be there. Handling big data. So outside of the challenges will be in big data. So data storage, physical storage, acquisition cost, space cost. This huge amount of cost, how they're going to handle, how the way they are going to store. So in data warehousing, we are going to store into the target database, any kind of databases. Okay, the same kind of if you're going to store into the any RDBMS, how it will be handled. Okay, for example, 1 million or 2 million or records are there. If you do the select star from the table name, what happen? It will take the it will hang the database, right? We have the table, one table, we have the 2 millions or 3 millions or 10 millions records are there. If you do the select star from the table name, so that the data will be hang and then it will be crash, or it will take 1 hour to get the result. Okay, so those things, everything will be they're going to handle by the big data, and also how they're going to process, ingest the 1 million records, how or unstructured data, anything, how they're going to process the very fastly, quickly from the source system to target system. It won't take the much time. Okay, so those kind of all challenges they're going to handle in the big data. How they're going to handle means we'll discuss here. So here in the big data, I'm showing the how they're going to handle means here. Okay, leave it. Otherwise, I can take for next paint. Okay. For example, this is my source data. This is my source data. Here will be there. For example, take will be 100 GB is there. Okay, 100 GB is there. So this 100 GB I want to load into the my target database. My target database has to how to load. Okay, so earlier in the data version, what they are doing, so same they will use the ETL tool. Okay, they will apply the transformation and then they are going to load the data to target database. But here, but big data framework, why it will be how it will be taking means. So this 100 GB before going to load the framework. So the big data framework, they're going to split into this data into different chunks. Okay, for example, each will be like that, chunks wise they're going to do the, so 1 GB 1 GB or something, depends upon the equal parallelism they're going to do. The split the data based on the how much data is there, that data they're going to split. Okay, that we call as a HDFS, Hadoop distribution file system. HDFS, this is the framework, guys. Okay, this is the framework. This is a big data Hadoop distributed file system. So this framework, it's going to split the first before going to ingest, right? So they're going to split into the this 100 GB data into different for sizes. Okay, different sizes they're going to split. Once the data is splitted, for example, take 1 GB, 1 GB, 1 GB. So in the one system, one CPU. For 100 GB means the same system will be there. This is another system. If I copy 100 GB at a time, huge amount of time again. So that's why they're going to 10 CPUs they're going to generate here, virtual CPUs. Okay, massive parallelism we call it as MPP, massive parallelism. That is handled by the framework guys, not for us. We don't think anything for us. Okay, so they are going to split into the each 100 GB means one system, two system, third system, the CPUs. The backend will be, so the system framework will be split into the 100 CPUs, 100 computers. Like in our terminology, let's take 100 computers. Okay, So now this undertaking again we have the one more framework is there, mapper and reducer. Okay, this is a mapper and this is a reducer. Okay, I'll tell you, this is a mapper, this is a reducer. So map reducer, the single one will be map reducer. So mapper is a separate framework, reducer is a framework. So this mapper, they're going to mapping. So whatever the mappings are there, they're going to generate the mapping. So like that, it will be mapped here. Okay, so all those things. So it will come, whatever the data is there, all 100 GB data it will come into. So they're going to mapping, and then again they're going to reduce this, all those things, sorry, all those things they're going to reduce and means combine the data, whatever we split it, right? 100 computers, the all 100 computers they're going to split into, by using the reducer they're going to split it, and then so load into the target database. So it will be 100 GB to finally it load the, this is will happen in the big data framework, guys. Okay, here the HDFS is on framework, the map reducer, we call it map reducer. So inside the mapper as a reducer, the framework will be same mapper reducer. So instead of map reducing, the mapper will be there, reducer will be there. Okay, like that how it will be handled means this is the happening in the backend framework. And then it's load into the data, into whatever the data, huge amount of data. This huge amount of data is going to load into the your target places. Okay, clear, guys? So, but in our ETL testing, the same thing it will happen, but by using the ETL tool, the Informatica tool, something. Okay, but here the framework will be automatically, the backend will be homework, framework will be take care everything. You no need to do anything. Once the connections, everything will be given properly. Okay, backend connections, the framework will take care the data, how they're going to split, how they're going to map, and then the reducer, everything will be happen. So whatever the data will be split here, that data they're going to use the reducer framework, it will be combined and then to load into the your places. So this is happening in the data warehousing, sorry, big data. Okay, we'll see. So Hadoop big data is just a overall definition highlight. So we call it Hadoop framework. So in the Hadoop is a free Java based programming framework that support the processing large data sets into distributed computing environment. So this Hadoop is a combination of the HDFS as well as the MapReducer. Just now I told the here. Sorry, where it is. So this Hadoop framework will be combination of the HDFS and the MapReducer. The combination of these two. So HDFS is the Hadoop distributed file system, and then MapReducer. These two frameworks are called as a big data. Okay, HDFS plus MapReducer is nothing but the Hadoop. Okay, so here in the MapReducer HDFS, what they are going to do means the HDFS will be cluster is a one system. As I told, the cluster is a one system, like the one in one virtual machine. Okay, so it will create the, we have the two types of clusters are there. One is the admin cluster, one is the data node, master node and slave node. Means admin will be handled by the all the data nodes. The work will be divided the admin into the all the how much data is there, 100 GB is there. This 100 GB will be, so they will parallelly they will divide into the each block, each data node. Okay, this everything will be taken by the framework, guys. So no need to do anything for us. Therefore we have to understanding the concept. Okay, in the HDFS again we have the two types are there. One is the master node, one is the slave node. One second. And HDFS will be master node, data node. Okay, master node and data node. So this master is admin. Okay, how much data is there? How many data nodes we need to create? Everything taken by the master node. For example, here 100 GB is there. Then how many data nodes will be required? Okay, then it will create this master node will be this many nodes. Okay, each node will be equally data will be splitted. Okay, we call the slave nodes, worker nodes. Okay, we call as a work node or slave nodes. Okay, this is admin node. So this admin node will be controlled by the data nodes. So this data, this 100 GB data will be stored into the here, the data nodes it will be stored. Okay. So here will be each under 1 GB, 1 GB, 1 GB like that. It will be create the data nodes. Parallelly, it will be create. Then it will be copy the 1 GB instead of copy at a time 100 GB. They're going to copy 1 GB, 1 GB. The parallelly. Okay. It will be easy, right? It will be quickly. It will be finish the data. Okay. This one. Yeah. So one each data node, one task MapReducer is there. For each data node, it will create the one task because he has to he has to process, right? That he has to map, right? So that is the reason. So each data node, they're going to generate one task. Okay. So if you have 100 data nodes are there, then 100 tasks are generated. So this will be taken with the MapReducer. Okay. So job tracker. This is also a kind of admin. So this job tracker they're going to handle by the this task trackers. How the this framework, right? HDFS will be the admin node will be there. The same way the MapReducer will be there. Job tracker will be there. So this is admin. Okay. We are 100 data nodes are there. 100 task trackers will be generated. Okay. I'll show you to clear understanding how the data will be splitted. Yeah, you can see the example. This is your source data. My source data, how it will be there? Deer, beer, river, car, river, deer, car, beer. So like that, we have the different data is there. So I want my output will be the target database. I want to load into the how many deers are there, how many bears are there, how many rivers are there. Okay. So like that. First, what I told map HDFS. So in the HDFS, what happened? It will split the data. Whatever the data is there, right? This data they're going to split into the multiple data nodes. So data, I told that two types of data nodes are there. One is the admin name node and is the data node. So name node is a master node. So master node will be handled by the all the data nodes, slave nodes. Okay. So these are the data nodes. So like that, they're going to each line they're going to split into the data first of all. Okay. Once the data is splitted, data node, the task generator will be generated. The mapping they're going to do. So deer will be one, beer will be one, river will be there. So like that, they're applying the mapping functionality in the backend framework, mapping functionality. Okay, like that in the backend will be the data will be mapper will be map. We call as a mapper framework. So this functionality will take care by the framework. Okay, once the everything data is shuffled, okay, then they're going to reducer framework. It will come to the picture. So how many are there? Bears are separating, cars are separating, deer separating. This one. So bear is 2, car is 3, deer is. Then your final result will be your target database. It will load into the. This is the output. It will load is like this. The same way it will happen in the real time also. Whatever the data we are getting, the huge amount of data, that is any format kind of data, they're going to first split the by using the HDFS. So based on the size, they're going to split here. So each data node by default will be 64 MB, guys. By default it will be there 64 MB it will store. Okay, by default it will be stored into the 64 MB. Or here is there huge amount of them, it will be made, they can extend up to 128 MB. Okay, up to 128 MB they can extend the data nodes. The size will be, they can able to increase. Okay, the by default size data node will be 64 MB, guys. For one data node size will be 64 MB. So this question they will ask in the interview. What is your data node size by default? So by default will be 64 MB. If you want, they can able to extend into the 128 MB. Depends upon the size of the data. Okay. For example, in that case, how many by the example 64 means here the size will be 100 GB. Then how many nodes they can create automatically? The admin node is maybe 300 or 400, something like that, right? 64 MB means you can take 1 GB means how many? 1024. And so for example, so I can take 1064 by 128. For 1 GB, they're going to create the 8 nodes. So 100 GB means 800 nodes they have to create automatically. 800 nodes they will going to create here. That will be taken by the name node. We call it as admin node. Name node or admin node both are the same. Okay. This master node. Name node is the master node. So 800 data nodes they are going to create here. Okay. Clear, guys? So functionality framework, is it clear? Any doubts here? So this is the big data analysis. Okay. So first they are going to split. For each split, they are going to the MapReduce framework. Okay. Once the mapping is happen, shuffling, mapping, everything happen, they're going to reduce the means combining the data. Whatever the data they're going to split it, right? That they're going to reducing. Okay. Then it's going to the output. Whatever the tables are there, each table way, they're going to load the data. So this is the functionality happen in the big data, guys. Clear? Any doubts, guys? Big data. The validations will be same, guys. Whatever we did the validation, the same kind of validations we are going to perform on the this source to this target. In between, we are going to do the same validations. There is nothing change. I will show you even the real time one to you what I did, the whatever I explained, same thing I'm going to do in the real time. I will show you that one. But the only difference is there they are going to use the ETL tool. Here they are going to use the big data framework. So whenever we mention in the resume big data means we have to know the what kind of terminology is there in the big data. What kind of framework, for example, HDFS. What is HDFS? What is a mapper? What is a reducer? What is Hadoop? Okay. So these kind of functionality you have to learn. They're going to ask the question, these kind of things they're going to ask. The real time. Okay. So I told what is HDFS? It's a Hadoop distributed file system. They're going to the HDFS is not a tool, it's a framework. HDFS is not a tool, guys. It's a framework. Okay, the framework will be handled by the whatever the source data is there. That source data they're going to extract, and then they're going to split into accordingly. Based on the size, they're going to split in the store into the different data nodes. Okay. Once the data is stored into the HDFS, okay, HDFS framework. Okay. Once then they're going to the framework, the MapReduce framework, it will come to the picture. The mapper and reducer, they're going to shuffling the data, and then they're combining the data by using the reducer. Then it will process the ingest the data into the target database. Like that, we have to explain in the interview point of view. Okay. Same thing, I'll share you guys this one. So what is a mapper? What is a reducer? Okay. So next, so the big data, as of now, how the shuffling functionality, how the data ingestion we understand, right? The mapper, reducer, everything we understand. Okay, but where we have to store the data, this one, this part you can discuss. For this, now they're going to generate the cloud systems. It came to the cloud system. Okay, come to the picture is a cloud system. There are the different kind of clouds are there in the market. Can you tell me any cloud environments in the market?
Azure, AWS.
Sorry, I can't hear you.
AWS, Amazon
Yeah,
Web Service,
Amazon Web Services, one cloud system is there.
Microsoft Azure.
Any other thing?
Microsoft Azure.
Cloudera, something. Okay, Azure Cloudera something. And then Azure, I think both are same. I think Cloudera, Azure. I'm not sure. Cloudera, Azure, and then Oracle Cloud is there. Okay, Google Cloud is there. Okay, Google Query, BigQuery is there. Okay, so these are the different kind of clouds are there in the market there. But one of the famous will be there AWS and then Azure. These two will be now in the market will be booming. One is AWS, one is the Azure. Next is upcoming will be Google is there. Okay, AWS is their own database is there. Redshift here. Here will be Redshift is there. Okay, the own database. The Cloudera maybe Hive. So we can able to use in the Hive also here. That is a big data tool. The Hive is a big data tool. Okay, so they're going to load the Hive also. Hive also another database. Hive and then Impala. One more database. Avro something is there. So these kind of databases are there in for a big data. So this everything can able to use in the cloud environment. Either Hive, Impala, Avro, and this is basically for the AWS tool, Redshift. Okay. Here we call it the Databricks. This is the BigQuery, Google Query, BigQuery. Okay. So, but the overall will be this kind of cloud environments are there, guys. Yeah. Okay. Now I'm going to show the AWS. What are the content will be there AWS? Okay. We'll see. Sorry. So cloud, what is the main purpose of the cloud means? For example, this kind of huge amount of data, we can't store, we can't maintain the servers in our environment. Okay. So every day will be the huge amount of data we are generating, right? So as part of the big data. So these kind of things they can't maintain in our own servers. For example, your laptop will be 1 TB max will be. So every day you are getting 1 GB data. How many days you can able to survive? Max for 1 month or 2 months you can able to survive in you can able to store in your database, your system, right? After that you have to increase again will be laptop size will be they have to increase. Apart from the size, they have to performance also we need to consider, right? So those performance RAM size also you have to increase. The hard disk also you have to increase. So everything you have to go every day potentially you have to increase the sizes. Okay. The same thing, that is the reason they can't maintain this kind of cost they can't bear the big data. Okay. That is the reason they go for the cloud environment, just like a rent. How we are paying rent and then we are still living right in a house. The same thing they're going to pay the some amount and then they're going to give for whatever the environment we required, what kind of servers we need. All the servers they're going to give for us. They're going to store the data into, we are going to store the data into their environments, cloud environments. The maintenance, everything they're going to just charge the rent. Okay, everything they're going to charge the rent and then they're going to store the data, they're going to maintain the servers, everything. So the cheap and best will be they're going to use the cloud environments nowadays. Okay, that cloud environment they're going to maintain the AWS, Cloudera, Azure, Oracle, Google. So these are the cloud environments so they're going to maintain the servers, the huge amount of servers, big servers they're going to maintain, the different kind of servers they're going to maintain. So our data will be, whenever we want, this we will open the server and then we can able to see the data. That's why in the real time they can't open every time in the servers. Always they're going to shut down the servers because of the we are open the server, it will be chargeable. If you didn't run any query also, so the server will be on, means each second it will be charging. Each second it is going to charge. Okay, that's why there will be so whenever we are not using, they're going to stop the servers. Okay, in my system they're going to the 10 something non-production environments, they're going to stop after 6 o'clock or 8 o'clock. They're going to shut down the servers. Again the morning they're going to open, because if you already open, means it will be automatically the charge will be cost will be happening every second, it is going to charge. Okay, how much you are going to use, for that purpose only they will charge. Okay, so that is the reason everyone they're going to move into the cloud systems. It will be cheap and best. The cost will be less. Then they can be the everything maintenance, everything they will only take care. We don't need to do the worry about the server and then cost. Whatever the server, we need to just pay the for that one. Okay. So backend will be big data framework. They're going to use these big data into this cloud environment. So the databases will be Hive, Impala, Avro, Redshift, or Databricks. So like that, different kind of is there. Okay. So Amazon Web Services, we call it Amazon Web Services here. Okay. So I'll just open how it will be the Amazon Web Services. We'll see. So I'm going to stop recording, guys.